When disaster strikes from above, when the impossible becomes necessary, when human hands alone cannot reach far enough or fast enough, we turn to machines that defy gravity itself. These are not just aircraft, they are heroes with wings, rotors and rocket engines, platforms that landed humans on another world, systems that saved entire nations from collapse, flying giants that do what nothing else can. This is the story of 20 legendary machines that changed what's possible in the sky. From the first powered flight to autonomous drones saving lives in Africa, from supersonic passenger jets to helicopters that lift other helicopters, these platforms earned their place in history, not through single moments, but through decades of service, doing what mankind physically cannot do alone. Let's count down the 20 greatest air heroes ever built. At number 20, we meet a machine designed to survive hell itself, the A10 Thunderbolt, nicknamed the Warthog. This is the only production aircraft built around its gun. The 30mm GAU-8 rotary cannon fires depleted uranium rounds at 3,900 rounds per minute. The recoil force equals the thrust of one of its engines. They literally designed the entire aircraft around this weapon. Before the A10, close air support meant fast jets making attack runs and hoping to hit ground targets while traveling 500 miles per hour. The Warthog changed everything. It loiters at low altitude for hours, it flies slow enough to identify targets precisely, and it survives damage that would destroy any other aircraft. During Desert Storm, one A10 returned to base with 6 feet of one wing completely gone, hydraulic systems destroyed, and half the tail shot off. It landed safely. 50 years later, no replacement exists. The F-35 cannot match its loiter time, survivability, or cannon effectiveness. The A-10 remains irreplaceable. 19th on our list flies a fleet that proves heroes come in small packages. Zipline's medical delivery drones. The world's first national drone delivery system launched in Rwanda in October 2016. In Africa, patients died waiting for blood products that sat in hospitals just 50 miles away, unreachable across impassable roads during rainy seasons. Traditional delivery took hours or days. Zipline's drones reach any location in their service area within 15 minutes. They launch from catapults, fly autonomously at 60 miles per hour. No pilot, no runway, no roads required. A child in rural Rwanda needs type O negative blood during surgery. The hospital has none. Zipline launches a drone carrying 2 units. Surgery proceeds. Life saved. Technology that exists solely to save lives. 18th on our countdown, we encounter supersonic elegance, the Concorde, the only supersonic passenger transport with sustained commercial service. For 27 years, from 1976 to 2003, it cruised at Mach 2, New York to London in 2 hours and 52 minutes. That record has never been beaten. Concorde tackled problems no commercial aircraft had faced. Sustained Mach 2 flight caused thermal expansion of 6 to 10 inches during cruise. The aircraft literally stretched in flight. Its engineers developed specialized high-temperature aluminum alloy and an automated fuel transfer system managing center of pressure shifts. The movable droop nose allowed visibility during takeoff and landing, while maintaining the needle shape needed for supersonic flight. Windows became too hot to touch, yet passengers inside sipped champagne in air-conditioned comfort while traveling twice the speed of sound. No commercial aircraft since has matched it. At 17, we find the helicopter that refuses to retire, the Boeing CH-47 Chinook, the most successful tandem rotor helicopter ever produced, with over 1,200 built. More remarkably, it's projected to remain in service until the 2060s, making it the US Army's first 100-year aircraft, continuously in frontline service for 98 years. The Chinook's tandem counter-rotating rotors eliminate the need for a tail rotor, allowing unrestricted rear ramp access. This design enables unique pinnacle landing capability on mountain tops, where single-rotor helicopters cannot operate. The counter-rotation cancels torque, providing exceptional stability for external loads up to 26,000 pounds. The CH-47 lifts 24,000 to 26,000 pounds, nearly 3 times more than a UH-60 Black Hawk, while flying faster at 170 knots. In Afghanistan, a Chinook airlifted an entire other helicopter, a crashed CH-47, off a mountainside at 12,000 feet elevation. The design proves so effective that after 62 years, nothing better exists for its mission profile. In 16th place stands the world's most advanced attack helicopter, the Boeing AH-64 Apache, the world's only all-weather night-capable attack helicopter with the Longbow millimeter wave radar system. It hunts tanks in complete darkness through smoke, dust, and battlefield obscuration. No other rotary wing platform possesses this capability. Its Longbow radar detects, classifies, and prioritizes threats automatically. The target acquisition designation site and pilot night vision sensor provide thermal imaging, allowing operations in zero visibility. The helicopter gunner's integrated helmet and display sighting system tracks where the gunner looks, slaving the 30mm chain gun to head movement. In Operation Desert Storm, Apaches fired the war's first shots. One Apache battalion destroyed over 500 Iraqi tanks and armored vehicles without losing a single aircraft to enemy fire. Over 2,400 Apaches serve in 16 countries. The Apache didn't just dominate battlefields, it redefined what attack helicopters could achieve. 15th on our countdown is the Marine Corps workhorse, the Boeing CH-46 Sea Knight, the longest-serving Marine Corps helicopter in history, with 50 years of continuous service from 1964 to 2015. Its tandem rotor design, like its bigger brother the Chinook, eliminated tail rotor vulnerability while providing rear ramp access for rapid loading and unloading. In Vietnam, Sea Knights evacuated over 3,000 wounded from hot landing zones, often taking ground fire while hovering to load casualties. The Marines called it the Frog. It wasn't the fastest or the most advanced, but for 50 years it delivered Marines into combat zones and brought them home. That's heroism measured in years and lives, not headlines. At 14, we meet the machine that scoops oceans to save forests. The Canadair CL-415, also known as the Super Scooper, the world's only modern purpose-built amphibious firefighting aircraft. While other firefighters adapted from military transports, the CL-415 was designed from the ground up for one mission: fighting wildfires. The CL-415 performs a maneuver no other firefighting aircraft can match. It descends to water at 70 knots, extends twin scoops, and fills 1,600-gallon tanks in just 12 seconds while continuing to fly. When seconds count and precision matters, when water sources are nearby but airports are distant, the Canadair proves that purpose-built engineering beats adaptation every time. Lucky number 13 belongs to the helicopter that carries its own swimming pool, the Erickson S-64 air crane. Carrying a 2,650-gallon water tank makes it the highest capacity firefighting helicopter in operation. More impressively, it can refill that tank by hovering over water sources and snorkeling up 2,600 gallons in 45 seconds. The air crane does what fixed-wing firefighters cannot. It hovers precisely, dropping water or retardant exactly where needed. It has lifted everything from air conditioning units onto skyscrapers to entire buildings during relocations. During Oregon wildfires, an air crane made over 60 drops in a single day, protecting structures by laying precise retardant lines just feet from buildings. They fight fires on 6 continents. they've logged over 2 million flight hours. The S-64 proves that sometimes the perfect tool for impossible jobs is a Vietnam-era helicopter modified with a tank and a snorkel. At number 12, we encounter the queen of the skies, the Boeing 747, the first wide-body jumbo jet and the longest continuously produced large aircraft, with production spanning 54 years from 1968 to 2022. Over 1,500 were built. Before the 747, intercontinental travel required multiple stops for refueling. Long-range flights carried fewer passengers. The 747 changed aviation economics forever. Its high bypass turbofan engines provided unprecedented efficiency. The wide body cabin allowed 466 passengers in high-density configuration. The distinctive humpback design resulted from placing the cockpit above the main deck, allowing the nose to open for cargo loading. This made the 747 the preferred heavy freight aircraft for decades. One 747 variant, the supertanker, fights wildfires carrying 19,600 gallons of fire retardant. NASA used a modified 747 to transport space shuttles. For 50 years, it connected continents, moved economies. The Queen of the Skies earned her crown through half a century of unmatched service. In 11th position hovers America's utility helicopter, the Sikorsky UH-60 Black Hawk, the most widely used military helicopter among US allies, with over 4,000 built serving in more than 30 countries. It needed to carry more, fly faster, survive better, and operate reliably. Crucially, it incorporates crashworthiness features that save lives. The airframe and landing gear absorb crash loads. Seats have energy-absorbing systems. Fuel tanks resist rupture. In Mogadishu, 1993, the famous Black Hawk Down incident demonstrated both vulnerability and resilience. One took 6 RPG hits and multiple small arms fire, but brought its crew home. From humanitarian missions to combat insertions, the Black Hawk serves everywhere. After 45 years of service, with upgraded variants still being produced, the Black Hawk continues proving that the best utility helicopter is the one that works everywhere, every time. At number 10, meet the immortal Dakota, the Douglas DC-3 and its military variant, the C-47 Skytrain, the longest continuously serving transport aircraft in history. First flight in 1935, still flying commercially in 2025. 90 years of service. The DC-3 changed everything about air travel. Before it, airlines lost money on passenger flights, subsidized by mail contracts. The DC-3's combination of reliability, economy, and range made flying profitable. By 1939, 90% of the world's airline passengers flew on DC-2s or DC-3s. During World War II, over 10,000 C-47s served every theater, carrying troops, wounded, supplies, and paratroopers. On D-Day alone, C-47s dropped 13,000 paratroopers over Normandy. In 1948, during the Berlin airlift, C-47s flew over 100,000 missions, delivering 2 million tons of supplies to blockaded Berlin. After 9 decades, DC-3s and C-47s still fly, still work, still prove that great engineering never becomes obsolete. In 9th place, we meet the heavyweight champion of helicopters, the MIL My-26 Halo, the world's largest production helicopter since 1983. It holds an FAI world record set February 3, 1982, that still stands 43 years later. Greatest mass, lifted to 2,000 meters at 125,152.02 pounds. The Mi-26 doesn't just lift heavy loads, it lifts things no other helicopter can touch. In Afghanistan in 2002, it airlifted an entire crashed CH-47 Chinook off a mountainside. The main rotor measures 32 meters across. 105 feet in diameter. That single 8-bladed rotor requires 19,725 shaft horsepower, transmitted through a revolutionary non-planetary split-torque gearbox. During the Chernobyl disaster, the HALO flew missions dropping sand and boron onto the burning reactor core, exposed to lethal radiation that would have killed the crews of smaller helicopters in minutes. When you need to move something impossible, when nothing else has enough power, when the job requires a flying crane instead of a helicopter, you call the HALO. At number 8 stands a single colossus that could not be replaced, the Antonov AN-225 Mriya, the largest and heaviest aircraft ever built. Maximum takeoff weight, 640 tons. It was the only aircraft ever built with 6 turbofan engines. The AN-225 transported cargo that literally could not move any other way. Ultra-heavy, indivisible loads. Generator units weighing 190 tons. Space station components. Locomotives. The fuselage stretched as far as its wings, with a cargo hold 142 feet long, equipped with a built-in 33-ton crane. In 2020, during COVID-19, it flew emergency medical supplies worldwide. Then on February 27, 2022, Russian forces destroyed Mriya during the invasion of Ukraine. The only one ever built, gone forever. Its destruction left a permanent gap. Some cargo now cannot move at all. Lucky number 7 is the immortal workhorse, the Lockheed C-130 Hercules, the longest continuous military aircraft production in history, and it's a Guinness World Record holder. In production since 1956, that's 70 years, with first flight in 1954, the C-130 reaches places jets cannot touch. Dirt strips, frozen lakes, beaches, high-altitude mountain airfields. Its 4 turboprop engines resist debris ingestion on unimproved surfaces. The high-wing design enables truck bed height loading from the rear ramp. In 1963, a C-130 performed the only successful arrested landings and unassisted takeoffs from an aircraft carrier, the USS Forrestal. The demonstration proved that in an emergency, even a carrier could launch Hercules aircraft. 70 countries operate 2,700+ Hercules. For 70 years, the Hercules has proven its design so fundamentally sound, it needed little improvement. In 6th place, we encounter the rocket that broke the paradigm, SpaceX Falcon 9 and Crew Dragon, the first orbital class, reusable rocket, and the most launched orbital rocket in history. In 2024 alone, it launched 134 times. Before SpaceX, orbital rockets cost $100 million+ per launch and were thrown away after one use. Falcon 9 lands its first stage booster back on drone ships or landing pads, then flies it again. Some boosters have flown over 20 times. This reduced launch costs to $69.85 million versus traditional rockets exceeding $150 million. On September 15, 2021, Crew Dragon launched the first all-civilian orbital mission, Inspiration 4. 4 non-professional astronauts orbited Earth for 3 days at 350 miles altitude, higher than the International Space Station. SpaceX transformed access to space from rare and expensive to routine and affordable. 5th on our countdown is the robot that sees everything, the Northrop Grumman RQ-4 Global Hawk, the first high-altitude, long-endurance unmanned aerial vehicle, or HAL EUAV, with operational autonomy. It flies missions over 30 hours long at altitudes above 60,000 feet. Global Hawk changed the equation. No pilot fatigue, no life support systems, no risk to human life. It loiters over target areas for over 32 hours, providing continuous surveillance with synthetic aperture radar and electro-optical infrared sensors. During Operation Odyssey Dawn over Libya, Global Hawks orbited for 25-hour missions. feeding real-time intelligence to NATO forces below. It changed how reconnaissance operates globally. Some missions no longer require pilots at all. The robot that sees everything doesn't blink, doesn't tire, and doesn't stop watching. At number 4, we meet the shapeshifter, the Bell V-22 Osprey, the world's only production tiltrotor aircraft. No other platform can take off like a helicopter, tilt its rotors forward, and cruise like a turboprop airplane. The V-22 combines helicopter vertical takeoff with airplane speed and range. The Osprey cruises at 316 miles per hour. Helicopters have combat ranges around 100 to 200 miles. The Osprey flies over 879 miles without refueling. This means Marines can launch from ships far over the horizon, fly inland at airplane speeds, insert troops by helicopter landing, then return. The V-22 doesn't just fill a role, it created a role that didn't exist before. The shapeshifter changed what's possible in military aviation. No other platform offers its combination of speed, range, and vertical capability. In third place, we encounter the untouchable, the Lockheed SR-71 Blackbird, the fastest air-breathing manned aircraft ever built. Maximum recorded speed, Mach 3.3 or 2,193 miles per hour. That speed record has stood for 49 years with no credible challenger. The SR-71 operated in a flight regime no other aircraft could touch. It cruised at 85,000 feet, where pilots could see the curvature of the Earth. At Mach 3+, air friction heated the titanium skin to over 500 degrees Fahrenheit, causing the airframe to expand 11 inches in length during flight. Fuel tanks leaked on the ground, sealing only when thermal expansion closed the gaps during supersonic cruise. The aircraft actually accelerated while climbing. Over 25 years of operational service, not one Blackbird was lost to enemy action, despite flying over the world's most heavily defended airspace. Over 800 missiles were fired at SR-71s, none connected. The Blackbird simply outran them all. The Blackbird retired in 1998. 27 years later, nothing has replaced it. At number 2, we honor the machine that birthed aviation itself, the Wright Flyer. The first controlled, powered, heavier-than-air flight in history, achieved December 17, 1903. More importantly, it was the first aircraft with 3-axis control, the fundamental basis of all modern flight. Before the Wright Flyer, humans could only watch birds and dream. The Wright brothers didn't just build a flying machine, they invented aeronautical engineering as a discipline. They conducted systematic wind tunnel testing, developed propeller theory, treating them as rotary wings, and created simultaneous pitch, roll, and yaw control. The Flyer's wing warping system controlled roll. The forward elevator managed pitch. The rear rudder controlled yaw. For the first time in human history, a pilot could fully control a powered aircraft in 3 dimensions. That first flight lasted 12 seconds and covered 120 feet, barely the wingspan of a modern Boeing 747. And at number 1, the greatest air hero of all time, the machine that took humanity to another world, the Apollo lunar module, the only machine to land humans on another celestial body. Between 1969 and 1972, it accomplished this 6 times, delivering 12 astronauts to the lunar surface with 0 mission-affecting failures. Over 50 years later, it remains the only human lunar lander ever flown. The lunar module operated in an environment where atmospheric flight was impossible. No air, no lift, no wings. It used rocket propulsion for both descent and ascent, managing landing velocities through thrust control alone. The 2-stage design proved revolutionary. The descent stage, equipped with landing legs spanning 9.4 meters between footpads, remained on the Moon while the ascent stage lifted off to rendezvous with the command module in orbit. This lunar orbit rendezvous architecture made Apollo feasible. The LM even served as a lifeboat during Apollo 13. When the service module exploded, 3 astronauts retreated into the lunar module, designed for 2 people and 2 days. It sustained them for 4 days, providing life support and course correction burns that brought them home safely. The LM's systems proved robust enough to exceed design parameters when human lives depended on it. Height: 22 feet 11 inches with landing gear extended. Mass: 33,300 pounds at launch. Descent engine: variable thrust from 10.5% to 60%, allowing precise landing control. Ascent engine: fixed thrust for lunar liftoff. First spacecraft designed to operate only in vacuum. Landing gear footpad span: 30.8 feet. 10 lunar modules launched with 100% mission success rate. On July 20, 1969, Neil Armstrong piloted Eagle to the lunar surface with just 17 seconds of fuel remaining. His heart rate hit 150 beats per minute during the final descent. On July 21, 1972, Gene Cernan piloted Challenger off the moon's surface, the last human to leave another world. No one has returned since. The lunar module wasn't the fastest aircraft on our list. It wasn't the biggest or the longest serving. But it accomplished something no other flying machine has matched. It carried humans beyond Earth and brought them home safely. It landed on another world 6 times. Every proposed lunar lander since has followed engineering principles the LM pioneered. The Apollo lunar module proved that human ingenuity can overcome any barrier, conquer any challenge, reach any destination. It took us to the moon, and someday when we return, it will be because the lunar module showed us the way. 20 machines. From the tiny zipline drone delivering blood products in 15 minutes to the mighty lunar module landing humans on the moon. From the Wright Flyer's 12-second hop to the Blackbird's Mach 3.3 scream at the edge of space. Each platform earned its place on this list not through viral moments or publicity stunts, but through sustained excellence doing things nothing else could achieve. These are the machines that changed what's possible. They proved that great engineering isn't about one successful mission, but decades of service delivering capabilities that extend human reach beyond what we can accomplish alone. They landed on the moon, outran missiles, fought volcanic eruptions, delivered life-saving medicine, transported millions across oceans, and redefined the boundaries of flight itself. The heroes of the sky don't seek glory. They simply work, day after day, mission after mission, proving that when humanity needs to reach higher, fly farther, or accomplish the impossible, we build machines that refuse to fail. And that's the true definition of heroism. Not fame, but function. Not headlines, but results. Not promises, but performance sustained across years, decades, and generations. These 20 platforms are legends because they do what humans cannot. They fly where we cannot breathe, carry loads we cannot lift, travel distances we cannot walk, and return safely every time. They are the air heroes, and their legacy is written not in words, but in the impossible missions they made routine. The next time you see an aircraft overhead, remember, you might be watching a hero at work.